Hello everyone. So in this video we will discuss the first synchronization mechanism solution which is implemented in with busy waiting mode. So I have already told you there are the synchronization mechanism solution is categorized into two categories. One is which is implemented in with busy waiting mode, and the other is without busy waiting mode. So first of all, we shall look at the solutions which are implemented in the with busy waiting mode, and then after we will look at the solution of without busy waiting mode. Okay, so this is the first synchronization mechanism solution, and it is called as lock variable. Okay, so lock variable is a synchronization mechanism technique. So you already know that whenever two processes or more than two processes wants to communicate with each other, then there is a synchronization needed between these processes so that the communication is communication is achieved, or communication is proceed successfully. Okay, and there is no chaos or there is no error occurred between them. Okay, so for that purpose we need to provide a solution, and here it is the first solution, and it is a software mechanism implemented in user mode. So the important point about this solution is it is implemented in user mode. So if any solution, if any synchronization mechanism solution is implemented in user mode, that means this solution does not depend on the hardware. So we can say that from this point it is architectural neutral, or it is portable. So from the four requirements of the synchronization mechanism technique, this particular solution is passed in one requirement, which is architectural neutral or portability. Okay, it is a busy waiting solution. So I already told you, first I will discuss all the busy waiting solution. So it comes under busy waiting solution, and it can be used even for more than two processes. So what does that mean? For more than two processes, there is not necessary that only two processes wants to communicate with each other. Sometimes more than two processes wants to communicate with each other and share the information across them. Okay, so for that purpose lock variable solution is suitable for those processes in which the number of processes are greater than 2. Okay, and most of the time we are only considering the solution which are implemented for only two processes, but here you can implement it with more than two processes. And the next point is lock variable uses only two values. Okay, so lock is a variable, okay, and it uses two values. When lock is equal to 0, then it implements that critical section is vacant. So vacant means any process can go into the critical section. If critical section is occupied, then no process can enter the critical section. Okay, so what is critical section? I already told you. Critical section is the shared resources or shared memory which are used by more than two processes or two processes. So for protecting critical section or shared resources, we need to use two values for a lock. Lock 0 indicates that critical section is not currently used by any process. So whoever interested in entering the critical section can enter the critical section. And lock is equal to 1 indicates that critical section is occupied. Critical section is occupied. Got it? So these two values are used to differentiate whether the processes are present in the critical section or whether the processes are not present in the critical section. Okay, so based on these two values we can implement the code of lock variable. Okay, so in the next video we will see the implementation of lock variable as well as their different aspects.